We're going to have a special guest presenter, Mr. Jeff Dale, sales manager from FLIR. And just so you know, T Equipment is a full-service test equipment company. We sell to all different segments of industry, and we cover many different aspects of test and measurement. Thermal is certainly one of the bigger ones we carry. And if you haven't been familiar with any of our websites besides tequipment.net, we also run thermalcameraexperts.com and also processcontrolexperts.com. So let's talk real quickly. Thermal imaging combined with other measurement instruments can help you find a problem before it finds you. FLIR, the world leader in thermal imaging cameras, has solutions that can help you save money by reducing unexpected downtime and find problems in both commercial and residential buildings, as well as electromechanical systems. And tequipment.net is one of the leading sellers of thermal cameras in the U.S. We have level 1 and level 2 thermographers on staff to help you with product selection as well as post-sales support. We keep many thermal cameras in stock and can also arrange for on-site demonstrations. As I mentioned, today's presenter is Mr. Jeff Dale. Jeff is a 14-year veteran of FLIR, and he covers the Carolinas and Virginia territories for them. So without further ado, I'm going to change this over to Jeff, and he will lead us through the presentation. Thanks very much for everybody for attending, and Jeff will be with you guys in a minute. And if you have any questions during the event, during this presentation, please feel free to use the chat window. I'll be moderating, so and I'll get any answers either for myself or through Jeff, okay? Thanks very much, everybody.
All right, everyone, welcome. This is Jeff Dale with FLIR. Hang on one second, I'll have my screen up for you. All right, Pete, how does that look?
Looks great, Jeff.
All right, well, we'll get started. Thank you for attending today. Thank you for taking time out of your day to learn a little bit about thermal imaging. Hopefully we'll be able to give you some insight and some information that'll help you as you go forward. At FLIR, we think of thermal imaging as the world's sixth sense. Basically, it really improves the way that we can see things, and we can see things in a totally different light than we normally would. In this example, you look over here and we're looking over in the woods. We really can't see anything that's going on over there. But with thermal imaging, we can see there's a guy standing back in the woods. Hopefully you don't have this application, but if you do, obviously the thermal camera is going to help you out. So who is FLIR? I want to give you a little background in who we are. FLIR's been around since, gosh, around early 1960s, so over 50 years now. And FLIR has many divisions in addition to the industrial group that I'm a part of. We have solutions for the military and defense, and with those, these are force protection cameras. These are infrared sights on rifles, on aircraft, things like that. Another group of FLIR is our Lorex division, and Lorex is a security division, and with Lorex we have lots of security cameras both for home and businesses. FLIR also offers solutions for the outdoors, and these are handheld cameras that the outdoorsman can use, but they're also rifle scopes that the consumer can purchase as well, not quite to the standard of our military equipment, but it's really very impressive how well these thermal rifle scopes work. Another division of FLIR is our Ray Marine group, and with Ray Marine, these are solutions for boat owners. Ray Marine has all sorts of things, GPS, depth finders, fish finders, all sorts of things that you would use on your boat. But today we want to talk about solutions for your work. What are some of the tools that you can use in your work to provide answers quicker and to help you remain safe when you go to work? When you look at FLIR and look at how we compare to other cameras within the market or other companies within the market, you can see FLIR has a pretty good market share. I believe it's well over 60% of the market. Now, What do you want to measure? We always talk about that because FLIR has more than just thermal cameras, although thermal cameras is a big part of what we do. As you can see here, this is a selection of cameras that we have available, and generally our thermal imaging devices range in price from around, say, $350 up to well over $100,000. Of course, with these there are different features along with a different price, but hopefully there's a solution in here that fits your needs and fits your budget. We also offer a full line of test and measurement equipment, both on the FLIR side where we have some of our premium test and measurement, and then also on the X-Tech side where we have a very broad selection of test and measurement at a very good value. So with thermal imaging, one of the things that we want to do is to find the problem, but to find the problem safely. And that's the most important thing, because it is a non-contact way of measuring the temperature. It leads to a much safer way to go about doing things. So why do we want to see heat? Well, in a general rule, a heat issue is normally an indication of a problem. In the case of the electrical connection over on the left, you can see one of these fuses is hotter than the other. Probably a loose connection, maybe it's a dirty connection, but for whatever reason, heat is, or the electricity is not flowing smoothly through that, and it's generating resistance and it's generating heat. On the motor, on the right side, you can see, we can look at motors and determine, is this motor running hotter than it should, and is this going to reduce the life of the motor? So what about the absence of heat? And when we talk about that, basically we're talking about cold. These are some examples inside a building, and these are areas where there's either cold air that's coming in due to poor insulation, poor weatherproofing, weather stripping, or it could be moisture issues. And moisture, because of the evaporative effect, will show up a lot of times as cold. As the moisture evaporates, it cools, and the camera sees that and recognizes it as a cold area. So it's not always heat that we look at. Sometimes we're looking for things that are colder. When you think of a common industrial environment, the most common application, the first place someone's going to take their thermal camera to normally is going to be to the electrical room. That's where all the electricity is. That's where all the components are that could heat up. But if you do that, you're really only getting part of the value of your camera. There are lots of other applications all over the facility, and you can see some of the examples here. So what is a thermal camera? Basically, it's a tool that allows us to see things based on how hot or cold they are. A thermal camera in a completely dark room could see, whatever's in the room because of its thermal profile. In this case, we're looking at this elephant. We're able to see areas that are hot and areas that are cold on the elephant. Now we have two glasses of water. Which of these glasses of water is hot? Which one is cold? Well, it's really hard to tell by looking at them, but with a thermal camera, we're able to tell that the one on the left is hot and the one on the right is cold. And not only can we tell, which is hot and which is cold, we can tell how hot and how cold. So it allows us to see things based on their temperature. A lot of times people ask, well, what is infrared? What is that? Well, if you look at the electromagnetic spectrum, you can see on our chart here where visible light is. Infrared is just to the right of visible light, and it's short of microwaves, it's short of radio waves, ultra high frequency and very high frequency. So it is a part of the electromagnetic spectrum. So how do these cameras work? Well, everything that is above absolute zero in temperature emits energy, And the hotter that thing is, the more radiation comes off of it. In this case, you can see, a glass of ice water is going to emit some radiation, but this fire is going to emit quite a bit of radiation. Well, once that radiation is emitted, we have to have something that catches it or detects it. And in this case, the photons impact the detector element within the camera, goes through the lens and detects and reaches the element. Then that element basically takes that, runs it through some calculations, and we have what's basically a spreadsheet that comes out with all of the temperature values for each one of those elements in the detector. From there, we add color depending on the temperature value. So in this case, we add these different colors based on how hot or cold they are. And from there, once we do that for the full image, we get a thermal image, and that's what comes out. Now, what's the difference between a thermal camera and a spot temperature gun? In effect, they work the same way, except a spot temperature gun only has one detector element, one pixel, whereas the thermal camera will have many, whether it's hundreds or thousands, or in some case hundreds of thousands of detector elements. In this case, a spot temperature gun or a spot or IR thermometer is used to measure the temperature of this wire. So we point it at the wire, we put the laser dot on it, and we get a reading. And if we're in the right position, we're close enough, things like that, it's going to be a fairly accurate reading for that wire. But you really don't know if you're in the right position or if you're in the right distance from it. So as you can see, that heat is striking the detector, and it gives us a reading of 100.8. But there's no image provided. So if there's another wire right beside it that's hot, we'll never see it. Or if one of the breakers down below is hot, we'll never see it. It only gives us a reading for wherever we're pointing that spot. On a thermal camera, it has multiple pixels or multiple sensors, and each one of them is calibrated to give us a temperature reading like we saw earlier. They allow for the color assignment, and then that in turn turns into that thermal image. The nice thing about that is when we save an image, we save the temperature values for every pixel in that image. So after the fact, we can go in and measure the temperature anywhere in that image, even places other than where we have this crosshair. In this example, it's 109.2, but it's not really in the hottest area. So we could move that crosshair up to the hot breaker and get the temperature reading there. Two important things to understand when thinking about thermal imaging and which is the right camera for you is resolution and spot size, and they're related. Resolution refers to the number of pixels in the image. In this case, this may be a low resolution image, and the one beside it is a higher resolution image. And you can see there are many, many more pixels in the image to the right than there is on the image to the left. These are some examples of what those images could look like on a camera. One might look more like just a kind of a temperature blob, where the other one you can make out components and have a much better image. So this is another example of resolution. As you can see here, the smallest thing we can measure is the temperature within 1 pixel. And within that, we're going to get the average temperature. So in this example, in 1 pixel, we have something hot, which is the wire, but we have some things that are cooler, which are the things that are in the background. Well, it's going to average that together, and our reading is not going to be as high as it could be. It's, in this case, 31.1 degrees C. Now, if we were to take a higher resolution camera, where we would have more pixels, as you can see, in each pixel, and the pixels are the ones that outlined in white, you can see in each pixel we're getting a more accurate reading because more of that pixel is filled up with the thing that's actually hot, and we're getting 40.8 C. But if we go even higher resolution, now you can see that we're getting the most accurate reading, and that is where we get 49.3 C. So depending on the camera and the resolution of the camera, we can get 3 different readings. We could get 31.1, 40.8, and 49.3. Now that doesn't mean that any of those cameras is not good or accurate. It just means that we have maybe gone beyond its capabilities. Maybe we're trying to measure something that's too small and we're trying to measure it from too far away. So it's a real important consideration to understand what your target is, how far away from your target you're going to be, how big it is, so that we can select the right solution for you. Another example, these are images taken from the same spot with different resolution cameras. And you can see we're pretty far away in these images. So with a camera that's pretty high resolution, 320 by 240 has a little over 76,000 pixels, we get a reading of 98.3. With a higher resolution camera, we jump up from 76,000 pixels to 307,000 pixels. That temperature reading goes up to a 123.9. If we were to jump up to our highest resolution camera, now we're going from 300,000 pixels to over 780,000 pixels. Now you can see a reading of 182.2. Now that's the most accurate reading of all 3. Clearly we were too far away with the first camera and really the second camera to get a good accurate reading. What we would need to do is either move closer, put a different lens on it, or get a camera with higher resolution. So spot size and resolution are very connected, and it's basically the number of pixels that we have and the way that the lens is designed so that we get the field of view of the lens. In this case, this is a device that has a 6:1 spot size ratio, and most of these devices you'll see that on the side, whether it's a spot temperature gun or an infrared camera. And what that means is I can accurately measure a 1-inch spot up to 6 inches away. Well, most people don't stand that close to whatever they're trying to measure. They think if they put that dot on it, they're going to get an accurate reading. But as you can see here, you're not going to. This would be an example. This wire in this engine compartment, we're trying to measure the temperature of this wire, but because of the spot size ratio, we're actually getting an average temperature of everything inside the yellow circle. Obviously that's going to be either much cooler or much hotter than the wire itself, depending on what the rest of this ambient temperature is, but it's going to be a lot different than just the temperature of the wire. So don't ever think that wherever that dot is where you're measuring. A lot of times it's a much larger circle around that dot. Another device might have a 24:1 spot size ratio. So with that, now we can measure that same 1-inch spot from 4 times further away. Instead of 6 inches away, now we're measuring from 24 inches away. And there's also, it tells on this chart, it gives you an idea, well, at 1 foot, how big of a spot could we measure as well. So back to that same example, we're going to get a much more accurate reading of that wire because the spot size ratio on this device is much smaller. So why is that important? Well, first of all, if it's energized equipment, the safest place to be is further away from it, not right up on top of it. So the further away that you can be, the better in terms of safety. As Pete said, I've been around for 14 years, and when I started infrared cameras were very expensive, in the neighborhood of $40,000 to $50,000, and so not a lot of people could afford to buy one for their facility. Nowadays, though, they're much more affordable. And when you think about the safety aspect of it, that brings a lot more value into the equation. In this case, we're looking at a failure. This is a loose connection, a termination failure. You can see in the general vicinity it's 114 degrees, but how hot do you think that failure is? Well, you can see here it's over 1,000 degrees Fahrenheit. You know, that's not long before that starts to melt and real problems show up. So think about the safety aspect of being able to find a problem like this before something really bad happens. And you can think about these tools as tremendous safety tools. CNA, which is a large insurance company, they do a lot of thermal studies. They do them for their customers. They do it as a service. They do it to make sure that you know, the customers that they're insuring, they can manage the risk of those customers. And they did a 5-year study in which they did over 6,000 infrared studies. Within those 6,000 studies, they found 47,000 problems or faults. That's an average of 7.3 problems or 7.3 faults per survey. And when they put a dollar value on it, the total saved was over $55 million, or an average of $8,533 per survey. When you start to think in those terms, if we went out into a facility and found, you know, problems that amounted to that, the payback on an infrared camera really becomes, you know, something that's fairly affordable. One of the things you'll start to hear when we refer to FLIR devices, and these are cameras and there are lots of other things as well, is this term IGM. Well, what the heck is IGM? Well, what that stands for is infrared guided measurement. And with infrared guided measurement, it means, you know, we're looking at this image and it's leading us to the thing that we want to put our emphasis on, whether it's to make the repair or make the replacement. IGM is not limited to an infrared camera, though. And when you look here, we've got a couple of devices on the left, an electrical clamp meter, a clamp on amp meter, and it has a built-in infrared camera. So you think about that, an infrared camera and a clamp meter, why would you need it? Well, as a guy is walking up to a panel, he's about to clamp that clamp meter around one of the conductors. Well, if he turns on his infrared camera and sees that one of those wires is loose, he's probably not going to take that clamp and clamp it on there and let it pull on that wire, because if it's loose, it could pull it all the way loose. He can also look for other issues within that panel, that area, that he might want to put his efforts into to make sure that he doesn't miss something. On the right is a similar type device for finding moisture. It's a moisture meter, and we can, of course, with that, measure moisture, but the nice thing about having a thermal imager is it tells us where to measure. We can see where the moisture is so that we know that we're measuring in the right areas. So infrared guided measurement is something you'll see a lot from FLIR currently and going forward. The clamp meter that we talked about with the built-in infrared camera has the ability to see the thermal image. It has spot temperature measurement. It's a true RMS meter. It has some great features like low Z mode for ghost voltage and a variable frequency drive mode. It also has the ability, this is a 600 amp clamp, but it has the ability with an add-on flexible clamp to go up to 3,000 amps. And you can see there at a price of $500, it's really a great value when you get when you think about a meter plus an infrared camera together, and you think about both the safety and the productivity that comes from having those two combined. So thermal imaging devices are very important for troubleshooting for 3 main reasons, and that is speed, accuracy, and documentation. When we talk about speed, if we were to take a look at this is a pad mount transformer. If we were to take a look at it with our eyes, well, we don't know which which one of these connections, which one of these elbows might have a problem. If we were to go up with a spot temperature gun, we might could find that. Certainly we could go up and grab them, but I don't think I would want to do that. But with an infrared camera, we can very quickly see that that top left elbow is hotter than the other. And so now we know where to put our emphasis. There's a lot of safety concerned with an infrared camera. The gentleman there in the middle is going down into a vault in a city, and inside that vault are lots of electrical connections. Well, one of the things he wants to do before he goes in there is survey the situation, survey this with an infrared camera to make sure there's not some loose connections, some things that could cause issues while he's in that vault. So he can very quickly find those problems, and even when he's in there, he can find those problems, document them, and get out of there. In terms of accuracy, we can pinpoint the issue very quickly. As you can see here, it doesn't take long for us to find that on the right-hand side, that looks like about the third breaker down is hot, and the wire coming out of that breaker is hot. Very quickly we can find that, and now we know where to start doing a little more investigation. You know, what's the cause of that? Is it an overloaded circuit? Is it a loose connection? Is it a bad breaker? This is a moisture issue where we've got moisture up in the top and down on the carpet. Again, very quickly we can tell the areas that are wet. Once we have found that problem, documentation is fairly simple, and with most FLIR cameras we can take these images, they're what we call radiometric JPEG images, and we can take them into reports, and in the report itself we can add additional measurement tools, boxes. We can adjust the image so that we add more contrast to it, and then we can generate the report. And a lot of times the report is an important thing. You know, here's a record of things that we found, and you can even on the report document that you made the correction. So let's take a look at some applications. First of all, the most important one I think for the group here today is electrical. You know, whether it's a loose connection, a dirty connection, or a corroded connection, they all are things that are going to impede the current. And when the current is impeded, it generates some heat, and from there we're able to pick it up with a camera. Of course, that heat is wasted energy. It's energy that's not going to do the job that it was intended for, and so we're paying money for electricity that we're not even using. You know, back to this example of 3 fuses, the one on the left certainly has some issues, and as you can see, it's starting to generate some heat. Maybe it just needs to be cleaned. Maybe there needs to be a replacement. Something needs to be done though, because we are generating some heat here, and it could lead to further problems down the road. Same thing here. If you look at the photo on the right, you know, everything looks good. You don't see any issues there. But once we look at it with the thermal camera, we can see, yeah, there's some issues with that middle fuse. We need to take a little closer look at it. Same thing with breakers. With any sort of electrical connection, maybe the nut is not tightened up on this one connection in the middle. Maybe it's a load issue. You know, we don't really know which one it could be, but we can definitely tell there's something going on there in the middle. Could be an unbalanced load, and that's where it would be important to use, you know, some of our other electrical equipment like our clamp meters. But you can very quickly see the load in the middle here, maybe that's the B phase, is a lot cooler, so maybe the load is less. On these switches, you can see the switch on the left, and there's definitely an issue there that needs to be taken into account. Same here on the control panel. A lot of times I've been in facilities and we've opened up control panels for different pieces of equipment, and it looks kind of like that photo on the right. There are lots of fuses, there are lots of relays, wires, junctions, lots of things going on. It would take forever to try to sort that out with a spot temperature gun, whereas with this infrared camera we can scan around and find problems like you see here and find them pretty quickly. All right, so again, looking at the photo on the right and then looking at the thermal image on the left, you can see, well, gosh, that one wire is a lot hotter than the one next to it. And in this case, we can tell what the difference is. Some of our cameras have the ability to even take it one step further and tell us what that difference is in temperature between the two. It has a delta function. Batteries, you think about batteries. A lot of times batteries, if there's a loose connection, it's going to heat up, and in this case it's pretty hot. We have 201 degrees where that connection is maybe not quite tight enough, whereas on the other parts of the battery it's only around 80 degrees. So that's pretty significant rise in temperature. Now, bus duct, this is that thing that's in the plant, it's up near the roof. No one really knows what's going on up there, but with the camera, we can look up there and see if maybe there's a loose connection that's generating heat. And one of the real important things to think about in a situation like this particular bus duct, we're looking at the outer cover, but this is not the thing that's heating up. There's bus inside of that that's heating up, generating heat, warming up the air inside, and that air is warming up the outside. So in this particular example, it's probably much hotter where the actual component that's heating up is, much hotter than what we're reading on the outside because of this being an indirect reading. Bus bars, as you can see, again, one of them is hotter than the other, and we can very quickly see that and start to work on it. Same thing for bus switches. Then outdoor connections as well. You might not be responsible for the electricity coming into your facility, but you may be. You may be with a utility and you're wanting to find out, well, gosh, where is an area that we could have an issue that might cause a power disruption with one of our customers, whether it's residential or commercial. And this is a very quick way for them to find that. They can see that this is heating up, and all of a sudden that becomes important for them to work on. Again, outdoor electrical, this might be a component in electrical substation down the road that you get your power from. And in this case, you can see this one component is over 500 degrees, whereas similar components nearby are anywhere from 80 to 100 degrees. Obviously, this needs some attention. So a lot like the images we showed earlier, where we're able to get a reading from a safe distance, depending on what camera you have and what the resolution and what the lens is, you can be further away and still get a good accurate reading. But always keep in mind, if you have maybe a lower resolution camera and you're trying to image things that are further away, you might not be getting the accurate reading. So it's very important to know I can measure objects of a certain size from a certain distance and know what that is, so that you won't try to get the camera to do something that it's not going to do a good job of. In all cases, we'll be able to tell that there's something hot, but if we want to get an accurate reading, then we need to have the right equipment. As you can see, the significant difference between these two different types of cameras and resolutions and the temperature reading that we're getting. Mechanical systems, and these are things like pumps, motors, conveyors, gearboxes, drive shafts, belts, pulleys, bearings, things like that. We're looking at this motor here, and if this motor is running hot, it's going to shorten its life. And the only way we can really tell if it's running hot is to take a look at it with an infrared camera. May not be the only way, but it's the best way. So you can see here a typical motor, if it's operating at 10 degrees C above its design, it's going to be, its lifespan is going to be cut in half. You know, that's probably a pretty expensive motor sitting there, and to cut its life in half, you know, we can really show a lot of payback to having a thermal camera by keeping an eye on these. One thing to keep in mind, we also have cameras that can be mounted in place near these motors and monitor the temperature and send it back either to some sort of PLC or back to some sort of monitoring system where we can monitor these all the time. You might not think of an infrared camera being a good tool to test the alignment of a motor, but in this case, you know, we have some misalignment, and you'll see how the flexible coupling starts to heat up due to the misalignment. The one on the right is, gosh, that's almost 30 degrees, right at 30 degrees higher temperature than the one on the left. So what's new with a thermal camera? What in the world do we have that's new? Well, years ago, cameras looked like this, and FLIR salesmen looked like that. As you can see, over the years, they've gotten smaller, they've gotten powerful, and the FLIR salesman's gotten more attractive. And there we are again. Now, one of the reasons that cameras have gotten more affordable is because of this. This tiny thing in this guy's hand is called our lepton detector, and that's a full thermal sensor and the lens. So basically, that's a thermal camera that needs, you know, just a few connections, some power, and a display, and it's ready to go. The lepton detector is the thing that we have in that clamp meter with a built-in infrared camera, the IGM meter that we talked about earlier, and it's in a lot of our thermal cameras. Because of things like the lepton detector, the cost of the technology has come down dramatically. You know, you can see here the TG165, that camera, that camera is around $350. We have a TG167, has a little different field of view. It's around $400. Our C2 over there, that's around $700. And so in terms of entry-level thermal imaging, these are great devices. We'll talk a little bit more about them. But, you know, going up from those up to some of our higher end cameras, you can see we've got quite a selection. And that's where, you know, the FLIR salesperson or the T-equipment salesperson can come in and help you determine which one's the best fit for you. Sometimes the best fit is just the one that's within your budget, but you know, we want to look at, will this do the job that we want the camera to do? And we can certainly help you with that. But you can see we have quite a selection here. Now, within the cameras, there are lots of different ways we can look at the images. In this case, this is a thermal image, pretty basic, and in this case, it's a wall. Now, apparently, there's some moisture issues in the wall. This is picture-in-picture, and with picture-in-picture, we've taken the thermal and overlaid that on top of the visual. So the things that we're concerned about, like the elbows in this transformer, are in thermal, but then we can see the rest of the transformer in the visual. The image here is a sort of blending, and it's where we take a percentage of the visual and a percentage of the thermal. And in this case, you know, maybe we're at 50-50, where it's 50% thermal, 50% visual. This is something we've had for a while, but it's almost a dilution of the thermal image. It's not one of my favorite ways to look at it because I think it really takes away from the thermal. Something that's new, and it's on all of our thermal cameras above that TG165 that we looked at earlier. On all of our cameras that have both visual and thermal built in, we have this feature called MSX. And what MSX does is it takes details from the visible image, and that's what you see there kind of in the middle where it says visible detail extracted. It takes that information and overlays it onto the thermal. So now in that thermal of the elbows in the transformer, normally we would see what was on the right, but with MSX now we can read the labels that are in there. If we're looking at a breaker panel, we can read the breakers, the breaker numbers, the breaker descriptions. So it gives us more information than we can use, that we can use. This is an image without MSX, and if you really squint, you might be able to make out, you know, there's something there in the background. But once we add the MSX, it really comes into view that we see, you know, what the scene is. We also have on some of our higher end cameras something called Ultramax, and with that we can really quadruple the number of pixels that we have, make it a less noisy image, and we can take an image that is normally 640 by 480 and transform that into just a unbelievable image, 1280 by 960. Beautiful image when we do that. With a lot of our cameras, we have the ability to connect up to the FLIR Tools mobile ecosystem. And with that, a lot of our cameras will connect up to smartphones and tablets via Wi-Fi. And not only can we see the image live streaming to the phone or the tablet, but we can control the camera. We can switch from visual to thermal. We can move the measurement spots around. We can save excuse me, we can save images and we can save videos. Also, as part of the FLIR Tools mobile ecosystem, we can connect our meters to our phones and use those as a remote device to see the screen. Basically, that meter has a reading of, I don't know what that is, 6,000 volts. Well, we would see the same reading on our phone, and that's a Bluetooth connection between those two. So which one's the right camera for you? Well, you know, as I mentioned, we've got low-end cameras, and when I say low-end, you know, they're low in price. They really have a tremendous amount of functionality, up to some really high-end, high functionality, high-resolution cameras. And in between, we've got lots of choices. So again, it really depends on what your needs are, how big your target is, how far away from the target you're going to be, that sort of thing. We talked about this earlier, the TG165, kind of our entry-level camera, is $349. It has a 24:1 spot ratio. We can save these images, we can download them. To turn it on, it boots up and is ready to go in just a couple of seconds. It fits in your pocket, and if for some reason you drop it, it is designed to be dropped and withstand a drop of up to 6.5 feet. It is water resistant if you're in a damp or wet environment, and of course it has a great warranty, 2 years on the entire device and 10 years on the detector, that lepton sensor that we saw earlier. The C2, this is a camera that is looks a lot like a cell phone, and it operates a lot like a cell phone. It's a thermal and a visual camera built in. It can go in your pocket. We have a lanyard where you can wear it around your neck. It does have MSX. It does have a touch screen, just like you would with your cell phone. And then from there we go up to our EX series. And when we say that EX, well, the X is any one of a number of different cameras, our E4 through our E8. All of these cameras have a radiometric JPEG image. They're fixed focus, so we don't have to worry with focusing these cameras. Has a 2.5-inch color display, and then the temperature range goes from -4 Fahrenheit to 482 Fahrenheit. The EX series does have the MSX feature that we looked at earlier. So in that series, there are 4 cameras. As you can see, the major difference is going to be the resolution. You know, we jump jump up pretty dramatically from the E4 to the E5, basically doubling the resolution. We double again up to the E6, and then we take a big jump up to 76,000 pixels there with the E8. From there, we get into our EXX series platform, and this is where we start picking up the Wi-Fi capability so we can sync up with smartphones and tablets, the Bluetooth functionality where we can connect with meters, and with this camera, we do have the ability to focus the lens. We have multiple lens options, so if you need a telephoto lens or a wide-angle lens, we have those available. The display is a little bit larger. It is a touchscreen display, and our temperature range is higher, so we go up to 1200 degrees with this series of cameras. And then within the camera, we have some advanced analysis modes, things like areas, spots, and things like temperature, colorization based on temperature. As you can see in this series of cameras, we have 3 different models, and they are different resolutions. Now, one thing to keep in mind and one thing to consider, both in the EX series and the EXX series cameras, we have an upgradability pathway to keep in mind. As an example, if I were to purchase an E40 and then down the road wish I had an E60, I can actually have that E40 upgraded to an E60. And the way that works is it goes back to the factory at FLIR. You pay the difference in price between the 2 cameras and a calibration charge. And then all of a sudden, we ship it back to you, and instead of an E40, now you have an E60. So it does give some flexibility if your needs change, your application changes, or maybe your budget changes a little. From there, we get up into our professional series cameras. This is our T-series cameras, and we have both the 400 and the 600 series cameras. These have great ergonomics because now if we're looking at something that's up higher than our heads, we don't have to hold the camera up above our heads to see them. We can hold the camera down and just tilt the lens to look up. So it has great ergonomics. Of course, with these cameras, we have the best resolution of all of our cameras, better optics. We have multiple options in terms of focus. And then some of these have features on where we can sketch on the screen, and some of the cameras have built-in GPS. So when we save an image, we can see via the GPS where that was saved from. Now, just briefly want to touch on the meters and the FLIR meters especially. What do you want in a meter? What is it that you're wanting to do? That's an important thing to consider. Most people will tell you they want something that's easy to use, that's very accurate, but that's tough and reliable. And it's, when we say ready for today, we're talking about ready to connect with smartphones, ready to connect with tablets. Heck, these meters can actually connect up with some of our infrared cameras, and the reading from the meter will show up on the camera. All of our meters are designed for a 6.5-foot drop. They have a limited lifetime warranty, which means it is a minimum of 10-year warranty on any of these devices. And within these meters, there are a lot of features that customers have asked us for, and these are things like that low Z mode that will find ghost voltages and basically rule that out, or our variable frequency drive mode that can really give us more accurate readings and filter out the distortion that you would get when you're working with a VFD. When we talk about our clamp meters, see they're a rugged design. We have lots of advantages in terms of the different temperature ranges and current ranges, or I'm sorry, different voltage ranges and current ranges. Depending on the model, some have some advanced power analysis, and of course, some of them have that VFD function we talked about. In every case, we have a built-in work light, which is a really nice feature that you may not have thought about, but having a light built into your meter when you're in a dark environment, that's one less thing you have to carry is a flashlight. And as we discussed, we can connect to smartphones and tablets and other FLIR cameras. We talked about the CM174. We do have some flexible clamps, and these are very unique in that this doesn't have to be connected to a meter. It's a standalone meter. It's a clamp, but it's flexible. We can measure current with this, and depending on the conductor size and what we're trying to do, we have two different sizes, and you can see the prices of these. Standalone flex clamp, 3,000 amps, has work lights. These are great if you want to measure inrush current. And inrush current is when you start up equipment and you want to see what happens. That current makes a big jump to start up with and then settles down. We can measure that. And of course, it has Bluetooth capability, so we can sync these up with our smartphones and our tablets. We also have the ability to do data recording, and these flex clamps do have the limited lifetime warranty. We also have a universal accessory, and this is a flex clamp that connects to existing meters. So this is available as well. And it doesn't have to be a FLIR or an X-Tech meter. We can connect to meters from other manufacturers as well. And this gives you some pricing on the accessory flex clamp depending on the size. And again, that goes up to 3,000 amps. Has the work lights, 3-meter drop rating. FLIR has a digital multimeter suite as well, and that's basically some various models with different features, but what's common is it's a tremendously rugged design. If you get a chance to hold one of these to check it out, you'll see how rugged these are, how well built they are. The display has large letters and numbers. We do have the illumination of the built-in work lights, some of the great modes like VFD and low Z, and then again the ability to connect with our smartphones and tablets. Well, that's it. Pete, I was looking at the chat. I don't see any questions. If anyone has any questions, go ahead and do that on the chat side. All right, good question. What is the greatest depth you can see with a thermal camera? And that's an important thing to understand. The answer is not very deep at all. The infrared cameras are looking at the surface, and sometimes you can take an infrared camera and look at the wall and tell where all the studs are. But that doesn't mean that the camera is some sort of x-ray machine that we can see through the wall. What's happening is where the studs are, either the heat or the cold from outside is transferring through those studs to the drywall and changing the temperature of that drywall ever so slightly, and we're picking it up with the camera. So in that case, we're really not looking much deeper than say the paint on the drywall. But because it is a different temperature where that stud is versus where it's not, we're able to pick that up with the camera. All right, next question was, how does thermal sensitivity help with looking for moisture? And it does a really good job. The more sensitive the camera is to small temperature differences, the better we're able to pick up moisture, even lower levels of moisture. In the case of, maybe there's a wall with moisture behind it, as it starts to wick through that drywall and as the moisture starts to evaporate, we can pick it up with the camera. Well, the more sensitive the camera is, the better it will be able to pick up those slight temperature differences, and we're talking, hundreds of a degree, sometimes thousandths of a degree difference. And the more sensitive the camera is, the better it will be able to pick those up.
Okay, Jeff, I think that pretty much covers it as far as the questions go from everybody. Everyone, I want to thank you all for joining us today on this webinar. We will send you a copy for follow-up. I think we have some documents we're going to be sending out to everybody, so thank you again for participating. Last chance for any questions for Jeff before we end this session. So I'm just watching the chat here. It looks like everybody's got a pretty good handle on these things. If you have any questions, you can always email me, pete@tequipment.net. Again, I'm the thermal sales manager here, so happy to help anybody with any questions they may have. And Jeff, once again, thanks very much for your time. We greatly appreciate you spending a little bit of time with us today.
No, thank you, everybody.
All right, have a great day, everybody. Take care.